coordination compounds. See, we have seen in the D block, DNF block elements, that they form large number of compounds which are actually called complex compounds. Complex in the sense that the ions which they give, that basically those ions doesn't dissociate to their individual components. So that is why they remain intact, and that is why we used to call them complex, and this is how we have complex salts or complex compounds. Now these complex compounds basically in actual reality they are called coordination compounds. And let me give you an example. The one which we use is like K4Fe CN6. It's called potassium ferrocyanide, a very commonly used lab reagent which you have been using or you will be using in your salt analysis number of times. What you find is this compound is a salt, and we call such type of compounds as coordination compounds. Why we call them coordination compounds? Or complex compounds, because the species which is kept inside the square bracket remains intact when this compound is even when added to water. It doesn't dissociate to individual ion. So when you are putting up this salt or this compound in water, don't expect that you will be getting Fe ions and the cyanide ions. This whole species remains intact. This happens so because this Fe is accepting pair of electrons from 6 cyanides like this through what? Coordinate covalent bonds or dative bonds. So these bonds, 6 bonds, are usually they are sigma bonds, coordinate covalent bonds, dative bonds. Both the electrons has been contributed by these cyanides, and as a result in polar medium or in aqueous medium, this whole species remains intact. Whereas, and it has having a 4- charge, whereas the forces between potassium and this whole ion are ionic, that is why it dissociates. So this compound is added to water, it gives us potassium ions and ferrocyanide ion. Not the ferrous ions alag or cyanides separately or the cyanide ions separately. It's not like this. So these compounds are called coordination compounds. Alfred Warner, who was a Swiss chemist, was the first one who studied these compounds and who was the one who actually worked on these compounds and came out with their formulas. So let us first understand these compounds as per the Warner's theory. Now, as per the Alfred Warner, who basically was studying these compounds, was not able to explain why these certain ions which are there, the certain molecular species are there, are not coming out as ions when these compounds are dissolved in water. And he was not able to know exactly the structures. That is why he used to call those ions as complex ions. And that is how they got their name, complex compounds. But yes, he was actually working on the Vent-Off factor like sort of things. He was experimentally studying those compounds, and that is how he was analyzing it. Like if I am talking about like this compound with molecular formula this, which is a compound of cobalt chloride and .6 ammonia, he was getting a Vent-Off factor 4. He was trying to find out why he was getting a Vent-Off factor 4. What about then 6 ammonia? The reason is because the 6 ammonia are forming a complex with this, and the 3 chloride are lying outside. So 1 ion we get this, 3 ions of chloride, that is how the I comes out to be 4. So this is how he studied all those compounds, and with a lot of experimentation, and then he came out with his own postulates and theory, which is called Warner theory.